This Algebra Nation podcast will cover page 2 times 21, problem square root 100.
Now, his parents told him the most he can spend is $75. So that is the most that he can spend on new shirts and pants for school. Now, he knows that he's going to spend $35 getting new shirts. He's already figured that out. He knows that pants are $8 each. Well, how many pairs of pants can he buy if he needs to stay in his budget, if he needs to stay within that $75? Let's figure it out. All this is an inequality. We can take this problem, create an inequality, and we'll be good to go. Let's see what we've got. So the most that he can spend is $75. So what he spends, what Sean spends, needs to be less than or equal to or greater than or equal to $75. Well, how much can he spend? The most he could possibly spend is $75. Parents aren't giving him any more than that. That's the biggest possible value. So whatever he spends needs to be less than or equal to $75. The most he can spend is $75. Everybody see that? Okay. This is the same thing as saying, all right, 75 is the most that he can spend. 75 is more, right? It's going to be the most, it could be that value. $75 is the absolute most that he could spend on clothes. Saying that what Sean spends is less than or equal to $75 is the same thing as saying $75 is the most that he could possibly spend. You're just looking at it from the different direction. So depending on how you initially attack this problem, you can set it up either way. Let's stick with our first one. Let's stick with this right here. We have what Sean spends needs to be less than or equal to $75, right? Whatever he spends, it needs to stay in the budget. Okay, well, what is he spending money on? He spends money on shirts, plus he spends money on pants, right? $75, he's got to buy shirts, he's got to buy pants. So some of that money goes to shirts, some of it goes to pants. The total amount of money that he spends needs to be less than or equal to $75. Well, how much money does he spend on shirts? We were told that in the problem. He's spending $35 on new shirts. So he's got $35 being spent on new shirts, plus the amount that he spends on pants needs to be less than or equal to $75. Well, how much is he spending on pants? For each pair of pants that he buys, he has to spend $8. Each pair costs $8. So if he buys one pair of pants, he spends $8. If he buys two pair of pants, he spends $16. For each pair of pants, we'll call that P, he spends $8. $8 times the number of pants that he buys, the total amount that he spends on pants. Well, guys, we just set up an inequality. All we need to do now is solve for P. Solve for the number of pants he can buy. Okay? We've got our amount spent on pants, and the added that we spend on shirts, the amount we spend on shirts is being added to it. So how do I get rid of this? It's a positive 35, so I'm going to subtract. Whatever I do to one side, got to do to the other. So 35 minus 35, that's going to cancel out. We get 8p is less than or equal to what? We're subtracting. We're not dividing by a negative, so we don't need to change that sign. That's why we just keep it less than or equal to. 75 minus 35 gives us 40. All right, the total amount that he spends on pants. Because remember, 8 times p is the total amount that he spends on pants. He can't spend any more than $40. He needs to spend $40 or less on pants. How many pants can he buy then? Well, for each pair, they're $8, so let's figure it out. We're going to divide both sides by 8. The number of pants that he can buy is less than or equal to, what's 40 divided by 8? 5. So he can buy 5 pairs of pants, 4, 3, 2, 1, or 0. Can't buy a negative number of pants, right? So we know that he can't buy any more than 5 pairs of pants. He's got to stay in his budget. So he can walk away with a bunch of shirts and spend $35 on them, and he can walk away with 5 pairs of pants and will still be in budget. The maximum number of pants he can buy is 5. Can he buy 6 pants? No. If he buys 6 pairs